Yes.
So I sent you an email last night, like really late, and so you probably haven't seen it yet. So my concert partner, Emma, and I were in the sixth period, and we're having trouble like doing our like semester because on the side here like the calendar, like something to do, which is like a lot of writing, and we're not really like certain on what we want to do. Like we got ours like approved by you, but then we're like we don't know how to go from here.
So we need to come up with a plan. Yeah.
And
So, yeah, so we can, we should meet about it.
I
And
texted you, or I emailed you and I said, can we meet after school? If you're not free, that's when we can do
I
it.
mean, after school today. I can't, and, but I can. So, teachers have to leave right away for home. So I'm leaving like 3:05 to be, because they load up here for the homecoming parade or something with all the stuff. So, but you know what I did on Monday? I Google Meeted with students, and I had their science here open, and we went through and filled it out together. Yeah, so, but I mean, like I can still work Friday afternoon or evening, and that way if you two could get together, and the Google Meet is just in, what do you, could you put it in the, what are you doing?
Checking the answer to everything.
Can you put it in the folder for me, please? I guess some others didn't put it in the folder. Thank you. So, you know, just email me what time works for you and your partner, you know, because even if you're not together, we can all, the Google Meets just wants to really be in the course information folder.
Okay, and is there like a date for that? Like, so on the calendar for assigned here, it says that it's due or start or something on October 6th and 7th.
Uh-huh.
But will it be late if we turn it in later?
No, because you came on me.
Okay. Thank you.
That's all you need to do. Let me know.
I left my quiz at home today, and I'm going to Manhattan for track at third period right after at 11. So can I come early third period and just take it here again? Okay. And kind of a late pass for that. Okay. Thank
It's already signed.
you. Are you here like right after school?
I'm not, this is the only day I'm not, because we have to leave for the parade to set up.
Oh, so the quiz has to be turned in now.
Yeah.
All right. What about third period?
Yeah, no, today.
Oh, today?
Yeah.
So like, what about right after school?
No, I'm not gonna risk it, because if I can get out at 2:55 and lock my door, I'm locking the door.
I have gym, so I could like run over here.
That, if you miss me, you miss me.
All right.
So it's what
Okay.
risk you want to take.
All right.
I have told you we have to leave so they can set up for the parade.
Okay. Understand. I got a pass.
They're right there, already signed. Ken?
Yes.
Blinking lights over there in the folder.
Right there on the table. So that's our other classes. That's their test.
Oh, yeah.
Let's go. Let's go. I actually studied too.
Spanish homework, by the way, because you never posted. We have.
Oh, I'm shooting today.
Bro, I wish.
No, like everyone.
Please put your phones in the lab. It's 8:09. Please put your phones in the lab. 8:09. Zane, it's 8:09.
I think it's so funny. Oh, you don't like these?
No, not that. I don't know what it is.
I always thought it was pretty easy. Sorry, I'll be back in a few
I think it's on.
Your headphones.
For those students who are participating in the homecoming parade, please look carefully. If any students are driving the parade, make sure you have your license, registration, and proof of insurance, and give full attention while driving. For those walking the parade, please pay attention to spaces right of the road, especially on Ollie Lane. If anyone is passing out candy to kids along the route, please be careful and alert the traffic. At the end of the parade, please move all the way up the school parking lot to make room for the rest of the parade. Thank you for your cooperation. I think for everyone interested in joining the Winston High School chapter of the National Honor Society, there will be an interest meeting for NHS and cafeteria to witness after school. The application serves our attendance requirements, induction, and volunteer opportunities will be discussed. NHS is forward to senior. The Winston Red Cross Club will be holding an orientation meeting on Tuesday, October 11th at 3 and cafeteria. This is a mandatory meeting for all new and returning members. Are you interested in winning snacks and a free t-shirt? Tea Club is having their first drive on November 2nd. Donate blood anytime during the school day. If you're at least 16 years old, weigh 110 pounds. Grab a parent consent form from this room, 21 and have it turned in by Friday, October 28th. Service
What?
Squad. Thank you for your support.
No.
Congratulations to the September gift card winners. And Maida Delreddy and Liz Walters. Please stop by the SOSA office near the center and pick up your Amazon gift card. That's all for now today. Have a great day.
Okay, so if we look at the slide, hopefully everyone has picked up the 3 handouts. They're right up here as you walk in. Quiz today will be take home. So you'll get it before leaving class. So it's still open notes, just like it is in class. You have 2 cards to copy. So copy today's cards. There are 2 cards. Also, please get out your notes for the unit. You're going to need a calculator. And I still have about 8 lab books to check, but in general, everyone, please make sure you have your name and period somewhere on your lab book. And even kind of more importantly, if found, return to K101. So I've got out the bin of Sharpies up here, because some of you have some nice plastic covers and things like that. Use a Sharpie. Get your name and period on it, and if found, return to K101. Because it would be heartbreaking if you what's going on? Why were you wandering? Just bring me the Sharpie back, please. Oh. Just about finished the cards. Okay, so we're coming quickly to the end of the unit.
Just like think about it.
And we just finished ions. Yes, sir. I'm sorry. Just let me get here. Sorry. The calculator will always be in the doorway. Excuse me. I would like to start the lesson. we're taking notes. You don't want to do that in your lab book. Traditionally, students confuse what we're going to learn now with ions, right? So we just finished ions up. With the ion, obviously, different number of electrons, so we get a charge. Big picture, you need to be able to identify cations, anions, or anything on the periodic table. So hopefully you're comfortable with that. Cations being positively charged, anions are negatively charged. You need to be able to calculate number of electrons for any ion. Any questions with how to do that? So oxygen as an ion is called oxide. How many electrons would the oxide atom have? 10 or 6? I've heard both. Which ones? So you find the number of protons, which is Zane, what?
8.
And if it was neutral, there'd be 8 electrons, but you are correct. There are 10 electrons. These are the 2 extra. Maybe the 6, you're getting confused with the number of valence electrons. Those are the ones in the outer energy level. So yes, oxygen have 6 valence electrons, but just the number of electrons in an ion, you compare them to protons. With that, we did the electronic or the electronic structure around an ion, an atom, which could be an ion. But basically, we got a lot more complicated than drawing 2 little dots and rings. That was called the electron configuration. Electron configuration, so that's the S, P, D, and F sublevels. So we learned a lot more about the energy levels, and we ended with orbital diagrams, which is just another way of looking at electron configuration. But what the orbital diagrams tell us is how many unpaired electrons an atom has. And that's important because unpaired electrons is equal to how many bonds it can make, right? So it's good to know how many bonds an atom can make. Students traditionally confuse ions with isotopes. Probably because of the I. Ions with isotopes. So we did everything about ions, and now we need to leave that behind, right? We really explored ions and electrons and all that. So now we're going to talk about isotopes. Isotopes are represented by the mass number. The mass number. And a mass number, remember our X in your notes, we had an A position, a B position, a C position. C is where the charge is. This is on your card, so you don't have to write it down. A is where the atomic number is. And that's right from the periodic table. It's the whole number from the periodic table. B is the Bass number. Bass like the fish? No, I mean mass number. Just a way to remember it, Bass versus mass. Mass number, and the mass number is equal to the number of protons plus the number of neutrons. Protons plus neutrons. So in everything you've done so far, I haven't asked you about neutrons. You cannot find neutrons on the periodic table, right? They're not there. What's on the periodic table is something completely different. So the only way to find neutrons of an atom is to be given the mass number. It's the only way. And isotopes are just versions of elements, carbon, 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 that are lighter or heavier. So it's just like heavier or lighter people, they're still people. So carbon can be light, medium, and heavy, but it's still carbon because still have the same number of protons in the nucleus. How many protons in carbon's nucleus? 6. So 6 protons. If the mass is 12, how many? 6. And if the mass is 13, 7. And how if the mass is 14? 8. Everyone see how that's happening here? So the mass number is given to you this way. You know something is an isotope where you'll have the name written out, let's say uranium. And then dash, there would be a number. So uranium 238. That tells you ding, 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 it's an isotope of uranium, right? That is, if you see a element name dash and a number, that tells you it's an isotope. Another thing you'll see, uranium 238. You see it here. That also tells you it's an isotope of uranium. Most atoms have isotopes. Most atoms have isotopes. So this goes against Dalton's atomic theory. Remember, Dalton said all atoms of an element are identical. And what holds true is all atoms of an element have the same number of protons, but they can vary now in neutrons and in electrons. If they vary in neutrons, they're isotopes. If they vary in electrons, they are ions. Yeah? Cool. So everyone should have picked up an ion table. Did we pick up an ion table? I mean, ion table, isotope table. See, even I got it confused. Really? Got a new computer and now it doesn't have any of the apps it needs to do stuff. Whoever invented apps was brilliant. Okay, let me just see how bad it screws up the formatting. Ooh, hold on. I got it. Put your name and period across the top, please. And downloads. Oh, downloads here. And there it is. That's the top table. Oh, but woohoo! Don't need that. Woohoo! Isotope table. Okay, so you should be able to fill this out given the little bits of information that you're given, but let's go over exactly what the information is that you're given here. Oh, that's too small. Oh, that's too big. Too small. Give it one more. Okay, cool. So you're given a mass number. Remember, this is protons plus neutrons. The atomic number is the number of protons, right? So these two are the same. Atomic number is the number of protons. Number of electrons, this will equal protons unless there's a charge, right? And now number of neutrons we should get from the mass number. So this element has a mass number of 23 and its notation is Na+1. So the element is sodium, yes. Right, from the periodic table. What's the atomic number of sodium? 11. So how many protons? 11, absolutely. And how many electrons if it has a positive 1 charge? 10, right? It lost an electron. Excellent. So the protons are showing. Now, how many neutrons? So it's, right, you're gonna, the atomic number is protons plus what gives you 23. So 11 plus 12 gives you 23. 11 plus 12 gives you 23. Make sense to everyone? Okay, so boron 11 gives you the mass number. What's the atomic number? 5. So number of protons is also 5. If there are only 2 electrons, does that mean it's an ion? And what's the charge going to be on the ion? +3, right? +3, because it has 5 positive charges. Remember, these are positive charges. Now, how many neutrons if the mass number is 11? So 5 plus what equals 11? So 5 plus 6 equals 11. Now, to include this information on the nuclear symbol for sodium, the atomic number goes in A, and I don't think Word's going to let me do it. And the mass number goes above, right? A position, B position, and the charge is in C position for your nuclear symbol. What would I put here for boron? 5, nice. And what would I put here? 11, nice. See all that information in one nuclear symbol, right? A lot of information. Carbon 14, so what's my mass number? Right? And the atomic number of carbon? And so the number of protons? 6. Number of electrons? So yeah, you have no information otherwise, right? So unless you're told it's an ion, it's neutral. Unless you're told it's an ion, it's neutral. And then neutrons will be protons plus what? Give me 14. Yep. And then if I did the symbol, atomic number goes in the bottom, mass number goes here, then the capital C for the symbol, and I have nothing in the charge. Nothing in the charge position because it's not an ion. What does nitride stand for? Nitrogen, but the ion of nitrogen. Does it give you a mass number? How are you going to fill in the mass number here? Atom, add what? Well, because the atomic number is the number of protons. So you add the number of protons and the neutrons. So yes, absolutely. So my mass number is 14. Now, what is the charge on the nitrogen ion? -3, excellent. And then you, same thing that we've been doing. So the mass number is 14, the atomic number is 7. So this is straight up practice, practice, practice. Yeah, feel good about this practice? Okay, so I'm gonna grab that and put it over there and hold that off to the side. We have one more thing to learn. Average atomic mass. Let me make it bigger for people in back. Average atomic mass. So this is the big mysterious question. What's the decimal number? The decimal number on the periodic table. Right? What's that decimal number on the periodic table? It is called the average atomic mass. So the percentage at which each isotope occurs in nature is taken into account in a sample of matter, calculating the element's average atomic mass. Since it's an average atomic mass, that's why it's a decimal. But it's not a, we can't individually add up the atoms and divide by the number of atoms. It's not that kind of average. It's a weighted average. And let me show you why it's a weighted average. So this picture here shows you naturally occurring barium, and barium has each one of these isotopes. So that means that there is barium 138, and there is barium. Hey, what do you know about barium? Did you guys burn barium last class? What do you know about barium? Anyone? Barium, like you, barium. Barium, what? Yes.
Like heavily, deadly.
Yes, skull and crossbones, Jolly Roger, barium, right? Barium. So there is a barium 138, there's a 137, there's a barium 136, there's a barium 135. Where am I getting these numbers? Right off of here. There's a 134, there's a 130, and a 132. Now, I don't just add up all these masses and divide by how many isotopes that is, because, here, I don't know. Oh, here, can you guys see that? Let me make this bigger. Come on, you can do it. Bigger, come on. So in that sample of barium, most of it is barium 138. Since most of it weighs 138 and very little weighs 130 or 132, I can't give them the same weight in an average. Does that make sense to you guys? So I have to let 138 count more in the average. So that's why it's called a weighted average. So you should have copied on your second card the weighted average for average atomic mass. Everyone have their second card out? So the formula for doing this is the sum. Everyone done this in math, that E is the sum? Well, that means sum. So if you just see that E, it's a sum. And it's the sum of the mass number. You're going to take the mass number and you're going to multiply it by the abundance. Multiply it by the abundance. Now, how do we define abundance? First, it's going to be a decimal number. It may be percentage or it may be a fraction. Maybe a percentage or fraction. And you do this for every isotope in the sample, right? So it's the sum of all of them. There might just be 2 isotopes, so you only do it for 2. If there's 6 isotopes, you do it for 6. So here is an example of the data you would be given. Copper 63, we know it's an isotope just because it says copper 63. They give us our mass number. Do I need that in the formula? Yep, I'm going to use mass number. And then I have to multiply that by percent abundance. So 63, I'm going to times it by 0.6917. Yeah? Does that make sense to everyone? How did I get 0.6917? Move that over twice, right? Divide by 100 to get it out of percentage. What do you get? Yes,
43.57.
okay, 43.57.
Mhm.
And that is for just this isotope, but I also have to do it for this isotope. So I'm gonna do 65 times, what do I switch this to? 0.3083. And what do I get for that one?
20.04.
20.04. Okay, so making sense for this part? So it's the sum that's important. Now you're adding these two up. You're adding this plus this. So there's no division in weighted average, right? You're not going to divide by 2. There's no division in weighted average. So what do I get if 7 and 4 is 11, 1, so that's 61, that's a 3, 63.61. This is the weighted average. A lot more of it weighs 63 than weighs 65. Right? Almost 70% weighs 63, so it makes sense that our weighted average is closer to 63. Now, if I just did 63 plus 65 divided by 2, what would I get? 64, right? But that doesn't work, yeah? So the paper that you're working on, please turn it over. Ooh. Last work. There is average atomic mass practice. Average atomic mass practice. Where is this? This shows you how to work it out, exactly what they did, adding it up at the end. And you will be working on these. You're gonna show all work with units to receive credit. It says rubidium is a soft silvery white metal that has 2 common isotopes, rubidium 85 and rubidium 87. If the abundance of rubidium 85 is 72.2 and the abundance of rubidium 87 is 27.8, what's the average atomic mass of rubidium? So why don't you guys try that right now? I'm gonna freeze frame. I'm gonna do it also, and then we'll see how we do. Okay, so everyone's right now working on number 1 and see how you do. Oh, I'm gonna make that pen a little better. What's going on? Do you need something? Oh, because there are calculators in the drawer. Scroll. 85.556. Yeah, Kwame, you look like no. You didn't get that? So remember to convert your percentages to decimals by moving it over to. And remember, once you get So 85 is the mass number times 0.722 gives you 6137. Did you get that?
So we need to divide by 2 then.
No, you don't divide by 2. There's no division in weighted averages. And think about what you're saying. 72% of it weighs 85. Why would its mass then be 40? Something, right? So there's no division. This is summing it up. You add this to this. That's what that pointy symbol means, sum. You add this to this. What do you think? You want to do another one? Yes.
Round it.
There's no reason to round. I mean, you see how long some of those get on the periodic table, right? So there's no reason to round here. No reason to round. And remember, counts are infinite sig figs, so you're good to go. You want to do one more? Okay, try this. I'm going to freeze the frame. I'm going to be doing it with you off screen, and then we'll check it out. Did I do something wrong? So to convert this percent, I have to divide by 100. That means moving this decimal over 2. So that means there's 3 zeros before my 1. Yes.
For uranium 235 at 1.645 when it's actually 1.6685.
What? 235.007. I got 1.645. Oh, so you did at 7.1. I did 0.7. So 235 times 0.0071. My bad. Good job. 685. So what does that change this to?
237.9783.
Yeah, 9783, and we go back to the 4 decimal places instead of 3. No wonder you were looking a little. Hey, that looks good. early in the morning. Really good. So we feel okay about weighted averages? Yes? Okay, so you have one more activity going on, so and I'll be done and you'll be getting to work on stuff. You should have picked up an activity called, anyone? I'm sorry? Benium isotopes. So, yeah, benium isotopes. It's kind of, I think it's kind of cool. So there is a pre-lab section that you need to do before going to the lab. And again, let me see if I can open it. Open. Browse. Benium activity. Yay, I can. Okay. So here is the benium activity. Sorry, I can't make it bigger for the back. So one way to understand the important concept of isotopes and average molar mass is to stimulate research on a new element called benium. You need only a container with a large number of assorted isotopes, which there is containers at every lab bench. So that's for every 2 people. There is a container. The container is a bag of beans. Each of the different beans are different isotopes, and you can distinguish them. We don't have to, you can distinguish them just by their physical characteristics, something we can't really do with atoms. So answer these questions before entering the lab. You may write the pre-lab on this paper. So this paper pre-lab actually doesn't go into your lab book, right? You'll turn this pre-lab in. In chemistry, what's the basic difference between isotopes of the same element? Pardon me? Number of neutrons. Can you make that into a sentence? Yep. And then here is a question. If there are 100 pinto beans, 27 kidney beans, and 173 black-eyed peas in a container, what is the percent composition of the container by number of beans? So now remember, what is percent? Part divided by whole times 100. So we're given parts. They're giving us the number of the parts. So the first thing we need to do is find the whole. So the whole would be the total of all the beans, right? So what's 100 plus 27 and 173? 300. So and it's asking what's the percent composition of the container. So we're just doing part over whole. For pinto beans, it would be 100 divided by 300, right? That is part over whole. And you'll multiply it by 100. And what do you get? 30%? 33%. You're going to go with 33. Is it repeating? Yeah. So 33.33. Not sure how we're going to leave this. Let's do the other ones and see. All right. 27 over 300 is what? You have to do it. Why not just do it now? 9%. It came out to 9. I'm sorry. 0.09 is 9%. So maybe we leave this at 33. Yeah. 9%. And black eyed peas, 173 divided by 300. 57.6%. And you say repeating. So that's 3 sig figs. That's 1. We can go with 1. So yeah, let's leave this at 30. 30%. Not that great, because shouldn't they all add up to something? What should all of these add up to? 100%, right? Because 300 over 300. 100%. Don't get caught up in sig figs here. Don't get caught up in sig figs. Understand what you're doing. Because you all kind of look scared when you read the question, or when I read it to you. But pretty basic, right? Pretty basic. Now, here's another one. Your chemistry grade is broken down. So 40% is exams, 40% on lab reports, and 20% on your homework. Your average scores are 65, 90, and 80. What is your grade? So this is actually accurate, right? So in class, 40% is on assessments, quizzes, and tests. 40% is on your lab book, right? And 20% is on classwork and homework. So this is a weighted average. So you've been graded by weighted averages this whole time. Everyone know how to do this. So we'll go, the exams are 65. So my grade, that's 65 is kind of like my mass. And how much, what is the abundance of that, or how much does that count? 40%, which we convert to 0.4, right? So that's my exams. It says 40% on labs, and my lab grade is a 90. So here's my 90 for my grade. And that is also 40%. And homework, my grade is an 80. What is it weighted? Well, it's weighted 20% or 0.2. So this is my homework / classwork. So 65 times 0.4 is 26. That's low. 90 times 0.4, 36. Oh no. And 80 times 0.2, 16. That's okay, because what do I have to do? I need to add them up, right? I need to add them up. So 16 plus 36 plus 26, and woohoo, yay, C plus. That's good in chemistry, right? Yes, sir. I can't hear you. For this one, what? Does it contain units? Points, maybe?
Are you not gonna write the like units like
But it's not asking about AMU. It's asking about what would your weighted average be for your grade. Is that what you're asking? Yeah. So this is just an example. What would your grade be? So it's not AMU, atomic mass unit. And then think about this guy. Now in your lab book, you will copy the data headings and rows in your lab book. Please do not use lines. Please do not use lines. Yeah, don't use lines. And give yourself some space. So you have bean type, Number of beans, this is a count, so that's an infinite number of sig figs. Mass of the beans, this is in grams. Now, you'll notice benches through 8, you have little, these are my personal battery operated balances since Raymundo is also using the balances today. So battery operated means just please turn them off when you're done. So I'm not buying batteries forever. And some of the little silver ones, you can literally turn the lid upside down and use it as a weigh boat. Right, put it on the balance and hit 0, and it's kind of a nicer weigh boat than what you're given there. So you have those 2 things to finish, and you got 40 some minutes. Are we good? Doing whatever order you'd like. I'd probably do the beanium because you can do the other stuff later. And I'm here to help you out. Yes, sir. Oh, hold on a second. Hold on a second. No, not yet. Hold on. So. So something happened last class, and someone someone from this period absconded with something that belonged to someone else. And it's okay. It's okay, but stealing is wrong. Taking something that is not yours is wrong. And you're the one who got it taken. It's not funny. So that's okay. You guys are young, you're growing, you make mistakes. Not a problem. So I just want you to know that the main office, you can walk in there with anything and say, would you put this in Miss Johnson's mailbox? They won't ask your name. They have no idea what it's about. Nothing. Just put it in my box. Say, would you put this in Miss Johnson's mailbox? Doesn't have to have anything, but it's a chance to kind of, okay, I effed up, but screw it. You know, it's a chance for that to happen. And you make somebody quite happy. And it's kind of the ideal situation. And a couple of things you shouldn't do. Don't take something that's not yours. Don't vandalize. You know, try to keep make the place better than you found it. Don't steal puppies. Right? Anyone have any other golden rule kind of things? No? That's it? Okay. Fine with that?
Wait,
I don't know. I feel like that's.
That's good. For not using lines on this table, you mean just not tracing those lines already in there? Or
Yep. Just don't use lines. You have these lines to guide you, but you don't, and I say give yourself, you know, space so you can space it out. But be tight. So you'll put the number, right? And you'll put the number, and you'll put the number, then you'll move down, and you'll do and you'll move down. So you know where to write. but you don't have to write the lines.
Like I know that
Read the names and see if you can figure it out. Yeah.
For work, so it's asking you basically like how you find like these
This is not Yeah, so same one beam. The average mass is a single beam. What would be a better procedure for finding the mass of just one beam? What would be a better procedure? How do you know it's not good to win just one beam?
Well, because if you're finding like a total and you're putting it over what you have. And
No,
how
it's not asking you about percentages. It's just saying to obtain the mass of one beam. And they're small.
Yeah.
Right? So is it good to put one beam on a balance and say that's what it weighs?
Not necessarily.
Why not?
Because wouldn't it like not be accurate for like the decimal it's given to you like that? What it's like the number it's given to you is not going to be accurate because like well first like throughout like if you do multiple different beams and all
You hit it.
then just divide.
So would
So
you
what
just
would
have
be
to
better to do?
you could do like multiple trials of like but I don't know if that would is they're all different so finding the averages it's just like a bunch of
So you're given a weigh book which holds a bunch.
yeah okay
So does that help? What if you put 20 beans in that boat?
and you give them the mass
Uh-huh. And then what would you do with a mass of 20 beans to find the mass of one bean? Right? So kind of that evens out under
Yeah.
any of the little weird differences. So a better thing would be to mass like 5 or 10 or 20.
just a bigger
And then
amount
a bigger amount and then divide by the number of that you mass. Does that make sense?
yeah
Yeah, versus one, but you got it because they're all a little bigger. And
Yeah.
when you're, you got it. So that's all. Yes, sir. Or what? Northern Kidney and Lexington. Oh my God. So lentils are gonna be the other. The white one, lentils, they're white. Ah, shoot. Lentils are white. So we got. No, northern kidney and lentils. Northern is white. Kidney is, I only read the front of the lab, so I made these according to the front of the lab. So kidney beans look red, right? Those are kidney beans. And the northern beans are white. Northern beans are white. So we'll make the little tiny black-eyed peas. Yeah, so northern's white. Kidney bean, everyone knows, and the little black ones are lentils, so. Okay. My bad, when I said read the names, I thought it would be easy because of black-eyed peas. I read the front of the lab, I read this, and I made those. But, yeah, so I was like, how did I not get one of black-eyed peas? This little ice cream is black. So northern is white. Kidney beans, like a kidney, the lentils. I'll write that.
Well, no, I'll be.
So this is like for reference, right? So when you go to study, what's that? And that number. Right? So you're gonna learn a bunch of you just want to write them once. So when you go to study, you're like, why did I put that there? Oh, it's fundamental. Right, it'll come back to you. So, right, absolute value times 100. Don't include the intermediates. Right? So once you do this, you're telling me the math. But rank formulas, because we're gonna get into a bunch, and that is a percent error formula. No, but see, once, if you wrote it here, I need to see it again. Just one time. Because when you go to study, you wanna know what that is. Because, look, oh my God, I did it every time. And it's a lot harder to go, where'd that 10 come from? And where'd that 8.9 go? And then, you know, it's a lot harder. No, and then you take it over here and you did that, but you people. Color, and you change the designs to square. The other thing you want to do is mark the hottest part of the plane. Right, the inner and outer plane, top of the inner plane. Don't have the balance notes when you're analytical balance versus electronic balance.
Oh, I read the house.
Okay. You have not sure where the.
What am I on wraps?
That's about right now.
Mine is
Yeah. Oh. Yeah, probably want that. What
the other sheet you gave us for the like the front and the back that we did, you helped us out. Would you want to see if stuff I know across as well? Okay, thank you.
So. Oh.
Yeah, without lunch. But you can do it, later. Oh, you can always do it later.
So we keep this paper, right?
Yeah, or trying to set this.
Oh, true.
Keep this paper yeah, for now.
So it's my turn.
Let's do the math.
And then we go, there's no difference.
No, Evie.
Coming from the younger brother, I just want you to know, everything she says, makes it sound like you don't want to. All the time. No, but like, she says stuff like. At times, like, even weird.
I don't think it's.
Like, to save my own sanity, I had to learn, I don't listen to what she says.
Yeah, that's just like.
Should you compare? Did you? Yes, that's exactly what we should do. Yeah. No, you can't understand any of it. Then comes the bunch of dots.
Yeah, because it's the most organs, that would just reduce them from all of our events, like,
So your mass, 16 grams. Right? And this is how many grams? And then 38.6%. So this times that, and that equals this. Okay.
that doesn't make sense.
Yeah. And you need to know what dots.
I'm pretty sure it's not divide. Think about it, it's hard, think about it. We're having to go over them.
Great. Go near more underneath. And then what are these folders? And you couldn't have more dots?
So.
So
Clearly. I will walk you with the floor.
So
Thank you for your time.
166 total. So 64 lentil or northern. So you have both, so you should say lentil or northern total. Okay, describe. Here, this is, right, because you have this is. And does it make sense to you? Will your employer be able to follow it? Or someone doing research after you?
So, I was just wondering for.
No.
No, you did that wrong. Yeah, there's no way you got 4. If you did this divided by that, maybe if you did this divided by that, but you divided by the wrong thing. Okay. Switch it.
The number of.
Divided by I guess, yeah, that'll work. Fine by me.
Each hydro basically finding and then you find out that's
Yeah.
I still don't know what that.
divided and then you like now you become like
Oh, yeah.
You're probably right. I did. Divide by that, right? Yeah.
Oh, yeah. Picture pencil.
No, that's
Don't feel bad. I'm sorry. I felt like it was like this.
Oh, yeah.
I scroll.
Yeah, we're finding a massive function, they just divide it like, yeah.
Oh, wait, so. No,
Yeah, and then multiply that.
The total. No, I'm sorry. I just. Oh, so what do you?
Just divide.
But and this is me running on like what, 3 hours of sleep. I didn't do something like that. It's all pretty. What do you mean? I don't know you well. They can't. Yeah, no, sometimes I have to say they try to keep it like you remember that time oh yeah,
I feel total by the.
yeah.
It's fine, I already.
I just want to.
This is
Well,
what.
you're great. Oh, so you watch Chelsea for yeah. So I'm so how many are out? So like the bacon.
Okay, now.
Oh, it's this. Oh, no, it's a very long list. It's, we don't have the time to list them all up.
No, you just say no, it's better to like.
That's like never gonna see it.
Oh, yeah.
Oh, I have. We're supposed to. Oh, there we are. Oh, we have to do it. Yeah.
Yeah.
Oh, we are supposed to. Wait, so would it be? I know that. I know what you're talking about. I see.
Why did you remember the songs?
Wait, so Minecraft.
Yeah.
It's managed to be done as a laptop. They're still all the real.
You're gonna add it. Oh, the electrification.
Yeah.
Short answer.
No. If it was my, if it was, electrons negatively charged. Yeah. It's negatively charged. 6, that
Like, I'm gonna add.
But it's okay to have all those numbers. It's just like when there, when you look at the silicon and some of them, there's tons of numbers. Don't do it. So counts are infinite.
Like, how does
Single class. So if you have more, it's okay. It's okay. Counts are infinite. Counts are infinite numbers. And that's a count also. So it's okay to have.
But then I care, I'm like, no, I should try to actually.
Okay. So I'm gonna pass out the quiz. I need you guys to put it away. Put it away, put it right away, quickly, put it away, 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 put it away. There are multiple different versions and still open note, open periodic table, open calculator, right? Just anything that doesn't have a label, then you're good to go. As soon as it has a label, wait, look at it, put it away. Please don't look at the quiz, just put it straight away. In your homework folder or wherever you have things to do later.
Nine. Oh. Yeah. Yeah. Are we actually going to look at the element? No, I didn't look through it. That's for like. Okay. Oh wait, it is. Yeah.
Oh, yeah.
This is, you would just use this.
Yeah.
So, you know how it.
Oh, how do we get that? How it has to do with this? It's the average atomic mass, you're just using more detailed math.
Do we start the same?
Huh?
It's my answer for number 4. Actually.
It is not accurate because they are different sizes and shapes for each type. Finding the average of multiple beans instead would have more accuracy. So it's asking what would a better procedure be, not finding average. No, because how would you find the average?
By like, yeah.
Right? So the better procedure would be to mass like 10 and divide by 10.
That's kind of what I meant. But
Yeah,
I'll
but
explain
you
it.
know, it's,
Yeah.
yeah. If I have. Yes, yeah, you should finish everything at home. You should finish everything at home.
So all that I do, that's it.
Okay, let me.
Are you ready to go? Yeah, I'm ready. Well, I'm not ready.
Totally, focus, and we have a common goal, like, we're to do that task. Well, yeah. Finding any different ways you can strategize.
How hard is the
It's more stunning than how hard it is.
How prepared you are.
If you're really prepared, it's not.
Yeah, I spent 85 for 15 years. So, but it's worth for 8 college credit or other 8 college, 3 college credits. So,
I'm not looking for the right testing on everything. I got myself to. Maybe you can clarify that this is studying biology and get right college. Yeah, I like how don't get okay, that was everything else is fine.
Justin saying.
Everything supports 5.
Oh, yeah, I think we have like. Oh, yeah, I did. I know, like my son.
Are we just keeping this?
Finishing it.
It's where you should grade everything.
So we're turning this green back.
Did you show your work for the pre-lab part? I will show you. Huh? In the drawer labeled tape. Yeah, Yes.
Yeah, that's really my logic. See, like, I will.
Don't forget your babies. It's like, what's she doing with my drink? Have a good 3-day weekend.